This instrument is an oscilloscope, and we're going to look at how to set up its basic functions so it can make some simple measurements. The first thing is, what is an oscilloscope? Well, the hint is in the name. An oscilloscope is for looking at oscillating waves. But in a nutshell, an oscilloscope is used for measuring any varying voltage and seeing how it changes over time. A varying voltage may be produced by a signal source. An example of a signal source is this small microphone here. This microphone picks up the sound waves and converts them into a varying voltage through this amplifier, which we can display on the oscilloscope. If I switch on the microphone, you can see the sound wave of my voice appearing on the oscilloscope as a varying voltage. And if I shout louder like this, you can see the voltage is increasing. Also connected to the oscilloscope is a signal generator. A signal generator allows us to artificially generate waves of whatever frequency or voltage we want. Now, as you can see, this is a much cleaner wave than the wave we had earlier with my voice wave. This is because the signal generator produces a signal of pure frequency. Now, if I plug in the speaker here, you can see or hear the sound it produces and see it on the screen. Along with looking at naturally occurring waves, we can also use the oscilloscope to look at pulses produced by instruments. These voltage pulses, switching instantaneously between high and low, are examples of how information is stored in a computer in the forms of ones and zeros. These examples show us how we can use an oscilloscope to measure various waves of different shapes and sizes, but more importantly, we need to be able to actually measure the size of the wave. If you look at the oscilloscope screen, you can see that the waveform is overlaid with a grid pattern. This grid pattern contains a voltage scale and a time scale. The voltage scale is here on the vertical axis, and the time scale is on the horizontal axis. The voltage scale has a number underneath, allowing us to know which of these boxes, the values of them. Also, the horizontal scale has an associated number. With this, we can now see how the voltage varies over time. Not only that, but since we know what the horizontal time scale is, we can see how many cycles of the wave appear over a given time period. The number of cycles of a wave in 1 second is the frequency. If we look at the signal generator, we can see the frequency written down here as 1 kilohertz, which is 1,000 cycles per second. If I turn up the frequency dial on the signal generator, you can see the frequency number increasing. And also, if you look at the oscilloscope, you can see the amount of waves increasing. Also, if I put in the speaker to it, now we can hear the effect of changing the frequency. Likewise, if I increase the amplitude of the signal, we can see it increasing on the oscilloscope, and we can hear the effect with the speaker as we turn the volume up and down.